residual energy is above a predefined threshold value, it continue as a clusterhead for the next round. But if on the other hand, the clusterhead's residual energy becomes lower than the threshold, the current clusterhead should select a new clusterhead from the members in that cluster. So this selection is done randomly in original LEFCA protocol, but also we applied different ideas to this part of LEFCA. For example, selecting the cluster head with the highest remaining energy. For example, selecting the cluster head which is close to the existing cluster head. And also these ideas have produced some another new publications to us, and we obtained from this part approximately 5-6 new conference proceedings. And in cluster change decision, threshold value is very critical and very significant. I will explain now. Especially the cluster head energy is highly related with this equation, and it is highly related with wireless propagation equations and wireless behavior of the channel. So there is a crossover distance which is very critical for the wireless communication, and if any node's distance is higher than this crossover distance, it will lose its energy by the opposite proportional to the fourth power of the distance. So here the main idea is aiming to decrease the distance between the especially nodes and the base station. So here, therefore, we are using clustering approach, because when we use clustering, especially for the remote clusters, cluster head can collect information from the remote members. So this distance will significantly decrease below the crossover distance. For example, for our simulations, we have 100 sensor nodes in the field, and the dimensions of our field is 100 times 100 meters. And for these values, the crossover distance, the critical value, is 87 meters.
Yeah.
Any problem? Hello, can you hear? Is there any problem? Is there any problem?
No.
Okay.
No, sir. No, sir. Please continue.
Going on. Any problem? Okay. I continue. After the presentation, I will take some questions. Okay. After the presentation, we will take some questions, dear participants. Okay. I continue then. So this is our problem. We have here, as you see, some sensor nodes which are scattered to the field randomly, and we have a base station which is outside of the field.
Professor, you have been muted by someone.
Someone has muted, sir. Please remove, sir.
Participants, do not mute our honorable speaker. It's a request to all of you. Please do cooperate with us. Please do not mute our honorable speaker.
Can you hear now?
Yes, Professor. Yes.
Okay. Okay, we go on then. Now, these are the distance calculations for this problem. And let's see the important part here. According to these values, we thought the worst case situation. We thought that our cluster hat has the positions to 0, 0 at the origin, and the base station is located in this in these coordinates. So also we thought that there is only one cluster, and this node at the origin is the cluster head. So for one round corresponds to us collecting the information from the members and transmitting to this information to the base station. This is one round, you know. So for one round, how much joule energy will be dissipated by this node? So we made these calculations and we obtained this value. And here, for our analysis, you know, there are 100 sensor nodes, and each node starts to the measurements with 2 joules initial energy. So for this worst case, we then determined the threshold value, the critical value for LEFCA as 0.05 joule. So what does it mean? A cluster head will continue as a cluster head for several numerous rounds. When its remaining energy becomes 0.05 joule, it will be changed with another alive nodes from its associated cluster. So this value also can be changed. There is no problem. We can increase, but we cannot decrease because of this calculation, because it is very critical. Think about that. You are trying to collect information, especially for a critical application. For example, earthquake, fire rescue. So you should collect information, for example, in every 5 minutes, in every 10 seconds, especially you can think about body area networks, healthcare applications. So it is very critical. So the network connection is very, very important for us. So therefore, this value can be increased, but cannot be decreased. And if we increase this value, for example, to 2, then LEFCA will behave like leech protocol and leech-based protocols. So the novelty of LEFCA is here. Therefore, we are trying to find an energy-efficient solution to the wireless sensor network. And here we are trying to abuse the cluster head. Okay, any problem? Can you hear me?
Yes, Professor. You can continue.
Okay, then continue.
Voice is audible, sir.
Is it okay?
Yes, you are audible, Professor.
Okay.
You are audible.
Okay. Now, also we produced another new solution for LEFCA. It is Maltop LEFCA, and it has published in IEEE Access as a research article. So it uses all ideas in LEFCA, but also, in addition, it has multi-hop communications nature. Addition to the LEFCA, here also we have multi-hop communication nature. So I will show it now. These are the same things, so I'm going on. idea is like that. For example, this is also LEFCA network, but when we use relay nodes, then it will become multi-LEFCA. So, for example, we have here 4 clusters, and for example, the node 5 is our cluster head here for cluster 1, and here, for example, for cluster 2, 11 is our cluster head. 5 collects information from its associated cluster and then transmits this information to the neighbor relay node. And then this neighbor relay node also collects its related information, and in addition, the information of cluster 1, and it combines this whole information and it transmits to the node 20. And then this node is responsible to transmit the whole information from also the coming from the neighbor clusters to the base station. So there is a problem here. Node 20 will have a lot of network load. So here, especially for cluster 4, some additional things can be used. For example, node 20 will be used as supernode. It can start with more energy. For example, it can have not 2 joules, 5 joules. So this problem also can be solved. But here, its distance to the base station is very lower than these clusters. So it survives for more rounds. So this problem not highly affects the performance of the whole network. And here also some additional information about multi-LEFCA. We know them because it has same ideas between LEFCA. And also here, let's see some simulation results of LEFCA and multi-LEFCA. Here, for example, this is the impact of number of clusters. At the beginning, we try to define the optimum number of clusters for LEFCA. How can we solve this problem, and how can we define the best situation? So for LEFCA, according to these parameters, 100, 100 dimensions and 100 sensor nodes, the optimal number of clusters for LEFCA is 10. It works in best manner when we have 10 clusters in the environment. So also this is the random selection idea, and this is our intelligent selection idea. You know, in intelligent selection, at the beginning we are trying to find the best cluster heads at the formation stage, so it provides significant performance improvements when we compared it with the random selection. So this is the impact of the threshold value. As you remember, I said before, we can increase the threshold value, there is no problem, but we cannot decrease the threshold value. When we increase the threshold value, the performance of LEFCA, especially for lifetime, especially in number of dead nodes, decreases, but the aligned node distribution in the network becomes more scalable. So it is according to the application, it can be changed, there is no problem. It depends on the application. For where will you we will use it, okay? So also to monitor and to track the status of the nodes, we obtain the energy map of the network. And here some snapshots from the network. For example, for round 3,500, what are the status of their energies? Which nodes are dead? Which nodes are still alive? And different colors correspond to different energy levels. So also this is one more snapshot from the network, and these are the instructions for the energy map. And here also this result shows the residual energy according to the number of rounds. So in literature, for some studies, they use simulation time, but some studies, they use number of rounds. We decided to use number of rounds. As you remember, one round corresponds to collecting information from the environment and transmitting this information to the base station. This corresponds to one round. So for example, LEFCA approximately have 5,500 rounds lifetime when we compared with other protocols in the literature. And this is also some additional instructions. And this figure shows the number of alive nodes. All protocols starts with 100 alive nodes, and all nodes have 2 joules initial energy. At the beginning, all conditions are same. And as you see from this figure, LEFCA provides robust and scalable performance. Its performance approximately linear, so this is good. And this provides us to use LEFCA for several applications. But other protocols have, you see from here, exponential natures. And in a table also, we see the results and average lifetime and the maximum lifetime. These results are obtained according to iterations and according to, for example, 100 different topologies which are generated again and again. So therefore, to obtain scalable results, we made average for them. And also here I put the maximum lifetime values of the protocols. And LEFCA, you see, provides again here additional energy savings and network lifetime improvements when we compare it with the existing protocols. Also here we looked at the total data transmission to the base station. What will happen when we check this result? LEFCA has very significant performance improvement when it is compared with the other protocols, because in these protocols the cluster formations are done randomly, and for some rounds some clusters are not formed. Also for some rounds any clusters are not formed, but for LEFCA, for each round we have clusters because it has fixed cluster nature, and we can collect for each round from any part of the network information. So especially this result shows that LEFCA is very suitable candidate, especially for healthcare applications and especially for critical applications, for example, fire rescue, fire measurements, earthquake measurements. So for critical applications, LEFCA can be used and it is very easy to deploy. Also, for different number of nodes in the network, we obtain obtain some additional results. What happens when we decrease the number of nodes? What happens when we increase the number of nodes? And what happens when we increase the dimensions of the field? We made also some additional evaluations. So, and also what happens when we put the base station inside the sensor field, because you know it is outside of the sensor field, it is remote base station. When we put it's in the middle of the area, as expected, the performances of all protocols are increased. So also we have some comparisons about LEFCA and MALTA-LEFCA for remaining energy. By using MALTA-LEFCA, we cannot obtain very significant improvements when it is compared with LEFCA. Also, nowadays, we are some new ideas and some new studies about MALTA-LEFCA. We are trying to increase its performance, and we are trying to solve its problems here. So this is also comparisons for LEFCA and its extension, M-LEFCA, MALTA-LEFCA, in data transmission and in terms of residual energy, in terms of aliveness, number of aliveness. Okay, as a conclusions, we made deep research in wireless sensor networks, and we found some problems, and we aim to solve these problems by using fixed clustering and threshold-based cluster changing mechanism in wireless sensor networks. Here, I presented to you LEFCA and MALTA-LEFCA, and they are both novel and good protocols when they are compared with the existing ones in the literature. And also they have still some problems, and we have to solve their problems. Also, we are open for collaborations with international collaborations. We can discuss together these problems, and we can produce solutions together. In addition, LEFCA can be for future directions. Also, I would like to mention something. With LEFCA, also Internet of Things can be combined. Software-defined networking approaches can be combined. In addition, LEFCA can be applied to heterogeneous networks. For example, maybe collecting information between some constant servers, constant data producers. Especially it can be maybe used for fixed networks in 5G, 4G communications. And also at the beginning, for clustering stage, some deep learning or machine learning solutions also can be applied to LEFCA to improve its performance. So for these topics, I'm open for collaborations with you. Also, some if we have here some PhD students, they can connect with me after their PhDs for postdoc researchers about these topics. Also, as our director mentioned, I have some studies about different topics. In addition, we have also studies about indoor positioning systems, 5G systems, power converters, also power electronics, and some other new topics. Also, I have some studies about machine learning, deep learning. So we can collaborate. You can email me and contact with me via Facebook or emails. Thank you for listening. So now we can discuss about some questions. If you
Participants, you are requested to raise your questions in the chat box if you have any. Or
okay, is there any
answer the
questions?
question.
Hello, hello.
Please raise your
Hello,
question
Hello.
in the chat box if possible.
Hello.
Hello,
I
sir. Can you hear me? Yes, yes. How are you, sir? I am Siddhartha
Yeah,
Chatterjee
I'm
from
hearing.
Kolkata, India.
Please raise the question in the chat box, Professor.
Okay. Nice to connect with you.
How are you, sir?
I'm fine. How about you?
Okay, I am fine also. Sir, I have total 3 questions. Okay, first question is, tell me some application area of LEFCA protocol, routing protocol in the wireless sensor network.
Okay.
Second
Let's
question.
answer and then ask your second question. Okay. One by one. I think we can go for first question, and don't forget your second question. For first question, yes, LEFCA can be applied to different fields, as I mentioned, but nowadays we don't have any application. We didn't apply it any real time or real hardware, so it is also open. So if you have relations with hardwares, we can discuss and we can apply LEFCA together, especially in software-defined networking manner. And maybe in a project, LEFCA can be tried, especially for healthcare applications with IoT-enabled or SDN-enabled sensor modes or nodes. So it is open. If you think and if you have some experience about these hardwares, we can, I think, easily deploy LEFCA to these hardwares. Okay. For second question.
Sir,
Hello.
can I ask a question?
Sure, please.
Yeah, sir, when you're finding out the neighboring clusters, you're using an Euclidean distance formula, right?
So,
Is there any other option to choose the neighbor nodes other than the Euclidean distance and the energy?
yes, also it can be option. Also, we have some ideas about that, especially determining the best neighbor selection or determining the optimum neighbor selection. By using distance-based novel approaches, also some new ideas and some new studies, papers can be I think produced from that part of LEFCA and also multi of LEFCA. If you have some ideas, we can discuss about them. You can contact with me.
Sure, sir. Thank you.
You are welcome.
Sir, which software you have used for this, sir?
I conducted my simulations in MATLAB.
Which
We use MATLAB.
software name, sir?
MATLAB.
Okay.
MATLAB,
Okay.
yes. We use MATLAB. Also, it can be conducted in Python or C++. It can be tried. There is no problem, I think. Maybe in Python, we can make further additional evaluations, especially for large-scale networks, because, you know, MATLAB, when we increase the dimensions, MATLAB becomes slower. So Python is more faster than MATLAB. So maybe in Python large-scale network applications of LEFCA can be done. Okay.
Thank you, sir. Sir, actually, you told that
You are welcome.
the node will
Participants, it will be better if you write your question in the chat box. Else it will be very difficult to end this session.
Okay, okay, sir. Okay, sir. The last question, actually, sir. Actually, the how the node will measure the residual energy, sir. Residual energy. Other nodes' residual energy. How one node will find it?
Residual energy. Can you again ask, please? I couldn't hear some parts of it.
Sir, the node will choose its cluster based on the residual, based on the energy of the another node. How we can find? How we can calculate the residual energy for
Okay.
choosing the cluster heads?
It is clear. I understood right now. Now, for example, let's think that you collected information from the nodes, especially you collected, for example, measurement about temperature. In that data, in that info, also you can collect their remaining energy levels for each round. So, according to those values, you can make sorting, and then you can select the node which has highest energy for the next being for the next cluster. Okay, while collecting the information about the measurements, you can also collect the energy levels of the nodes, because they have knowledge about their energy levels and they can send you energy status. Okay.
Yes, sir. Yes, sir. Thank you so much.
You are welcome.
Hello, Professor. I think we do not have any questions right now.
Okay.
Hello.
Hello.
Sir, how to choose the threshold value?
Threshold value, you mean?
Yes, sir.
Yes, for threshold value, we thought the worst case scenario in the network. For example, let's think like that. You have 100 sensor nodes and you have only one cluster. And your cluster head is the node which has highest distance to the base station. At the beginning, you start with worst case, the bad situation. And for this case, one node is clustered and 99 nodes are members. These 99 nodes collect measurement from the environment and send this measurement to the one cluster head, which is at the origin of the network, 0 to 0 coordinates. So this cluster head then transmits the whole information to the base station, which is located at the 150.50 coordinates. So for this process, that bad node consumed how much energy? We calculated this value and we found the value, and according to this value, we decided the threshold value. Okay, for the worst case scenario, we decided the threshold value. Okay.
Yes, sir. Any theoretical algorithm or method is there to?
Any algorithm or? Can you please ask again? I couldn't understand.
Algorithm and method. Algorithm
method.
and
Random. Random method.
No, sir. Actually, she wants to know what kind of algorithm you are using or method you are using?
Okay. For this method, these calculations are done in MATLAB. We generate this situation by using the simulation environment, and we calculated this value according to the energy consumption model that we showed in the presentation. You see there is an equation. We use that equation. It is also a widely known equation. You can find in the literature energy dissipation of a node, energy dissipation of a cluster head node. When you search like that in Google for wireless sensor networks, you can find that equation. It is this equation is related with wireless communications. So according to that equation, we calculate this value. Okay.
Okay, Professor, we will not take more questions. And I want to thank you for this wonderful presentation. We hope that all of you have found this session very informative. And we are very privileged to have in attendance so many distinguished participants and our honorable speaker. We are very thankful to all the participants for your patience and cooperation throughout the webinar session. Here I would like to again thank our honorable speaker who has honored us by presenting this wonderful webinar. We hope to have the opportunity to listen from you soon again, sir. And now I will share the feedback form in the chat box. Please do not leave this session without filling up that form for the successful generation of the e-certificate. Let me remind you, you will receive this e-certificate within 14 working days in your email ID, which you will provide in the feedback form. Thank you all again. Thank you, Professor. Now I'll request our respected principal, sir, for the closing speech to end this webinar session. Thank you again.
You are welcome. Thank you for this opportunity also. Thank you for the listeners. For any collaborations, they can email me for future studies. Yes. See you later. Have a good night to my friends and also professors and students. Let's hope to meet you again in another presentation or another session. See you later. Bye-bye.
Share the feedback link.
Hello.
Hello. Sir, can we exit from the meeting?
Once you have filled up the feedback form, you can exit from the meeting. Thank you.
Okay, sir. Okay, thank you, sir.
Welcome.
Sir, where is feedback form?
It is already shared in the chat box. Okay, I am sharing it once again. Is there? You can check.
Okay, sir. It is not possible to open the link.
Yes, sorry.
Yeah, it is not possible to open the link. Is it valid?
Yes, it's valid. You just click on the link provided. It's actually working. It's no problem. There is no problem at all. Please try once more.
Could I find in the WhatsApp? Okay?
No. It is not possible to share this link in the WhatsApp or Telegram group. Please kindly fill up the same from the chat box in the link provided in the chat box.
Okay. It is clear.
Yeah, I have shared once again. You can find the same.
Okay. Yeah.
Sir, can you share the PPTs of today's webinar?
Once we get the PPT from our honorable speaker, we'll share the PPT in the respective WhatsApp and Telegram groups. Thank you.
Okay, sir. Okay, thank you so much. Thank you.
Yeah.
I couldn't open the link by Google Chrome. Is there any browser or suitable browser other than Google Chrome?
It will work in any browser. Please copy this link and we'll paste it in a suitable browser like Opera, Microsoft Internet Explorer, or Mozilla Firefox. The link is valid.
Yeah. Okay. Thank you.
But it is not opening, sir, other portal. Chrome is not opening, sir.
Yeah.
All boxes are not visible.
Links are opening in Chrome as well. Please try once more. The link is opening in the Chrome also.
No, in like Chrome it is not opening, sir. By
try.
default, it will take the Chrome. It is not opening.
Yes, it is here. Yes. By default, it will open in Google Chrome. If you are watching this webinar or was experiencing this webinar in the Chrome, then it will open it in the same browser. Or also it can open in another browser also. There is no problem.
Okay, fine, sir. Thank you.
Thank you.
Sir, how can we get the details, contact details of the presenter? Can we get?
Regarding details, what you want actually?
Sir, how can we contact? if we need some sort of guidance or some suggestions from him? Any email ID or
First I can do one thing. I am sharing out my email ID. Okay.
Okay.
And
Okay.
you will write me a letter regarding actually what you want.
Okay, sir. Okay. Fine.
Then definitely I will discuss with him, and if he agrees, then I will share his email ID with you. No issue.
Fine. Thank you, sir. Thank you. Thank you. So please you share your email ID.
Yeah, sure.
Sir, could you provide me with the Turkish professor mail email ID?
Yeah, actually same thing I have answered now, that if you have any kind of query, or if you want to collaborate with the speaker, then first I need a concern from his side. So what I can do, I am sharing my email ID here. Then I will forward the matter to him. If he give me a positive response, I will surely revert back to the respective mail IDs.
Okay, thank you.
You're welcome.
Sir, I have all submitted the form. I have filled it, but the form is not getting submitted. What is the problem, sir?
See, link is actually active. You check your browser, because already we got 185 plus responses. Already more than 180 participants submitted their response.
Hello, sir.
Yes, tell me.
Sir, I request you in the future, sir, I want to webinar on satellite communication as well as radar engineering, sir, if it is possible. So please, we will take radar engineering as well as satellite communication, which is very.
Actually, see, your demand is a perfect one, but question is, both the words are very fast. The satellite communication is itself a huge concept, huge domain, and radar is a different one. So you need actually specifically what designing of components for satellite communication, or the details about satellite communication system. What is actual requirement?
Actually, sir.
Actually, see
yes, sir.
Actually, in the chat box, I have shared my mail ID. If you have any proposal, you can forward me. I will definitely try to arrange. In a very short time, I am having a plan to organize a webinar for the I mean to say printed antenna or planar antenna or microstrip antenna for satellite communications. But that will be based on antenna for satellite communication, not on totally on satellite communication. So I need a specific demands from your side, actually, or proposal, what actually as an audience or active participants you want from us.
Okay, sir. Okay, sir. I understand the situation. Actually, my M.Tech is art and microwave engineering. So all.
Okay.
Sir, for the coming webinars, please raise the quality of the voice, if you could. Thank you.
See, may I ask you, you're from which country?
Yeah, I'm from Sudan.
Yeah, but here regarding the voice quality or video quality, actually no participants have made any suggestions or questions or complaint. Even we can see the honorable speaker clearly. We can hear his voice clearly. Actually, we don't have found any network issue from our side.
Yeah. Now your voice is more clear than in the webinar. Okay, thank you.
Yes, but I am continuously for the 1.5 hours sitting at the same place. Probably there is network issue in your side. As I can see in the video, you are roaming here and there. So there might be network problem.
Yeah, I am seeing a video is very well on the voice. Okay, thank you.
Yes.
Thank you.
Yes.
Thank you. Okay.
And Mr. Sasan Kumar, you were asking something. Please, you carry on.
Yeah, okay, sir. Pardon.
Okay, thank you.
Thank you. Thank you.
Sir, sorry to interrupt. I have some problem that I want the PPT of that that the speaker, if it's available, please please send it on the participant email or.
PPTC
Yes.
actually we did not normally ask for it. If there is a specific requirement from participant side, then I will just forward the request to him. Probably he will share it. No issues with it.
Okay, sir. You have sent me the this send the email, or I will send the request on your email, and please send me the PPT because I have PhD student.
I have given already. I have given already in that in the chat
Okay,
box. I have given my
I will send my I will just forward my request to you on your email ID, and please forward me on that on the same.
Okay.
Thank you, sir. Thank you.
Sir, in future, any other webinar is going to be?
Yes, on 9th, we are having a webinar that is related to electrical engineering. That is a material characterization of solar cell. It is related to photovoltaic applications. And
so, sir, as you have received all the emails in the form, so will it be possible to intimate us?
Intimate means actually, see, through different mediums, I have already shared the link in Facebooks or in more than 60 groups. I have already shared that things, or particularly if you search with my name in Facebook profile, then you can find the post I have already given. Registration link is also there. But every time actually we will try, because we are conducting since the 25th of June. So for each and every webinar, we are forming a WhatsApp group and also a Telegram group. So after providing the certificate, quickly we are dissolving those group also. So probably due to lack of time, it is not possible every time to share this information with the previous created groups. Okay, or you can follow the official page of IMPS College. There is also this post. No problem.
Okay, participants, I am sharing the official Facebook page link of our college. You can follow the same to get the information for the upcoming webinars. There is the official page, Facebook link of our college. Please click on the same. You can find the information regarding our upcoming webinars.